Yes, dear children, we will see now conformational isomerism. Okay, now here I have tried to represent one ethane molecule. Okay, ethane, you know it, is it not? Carbon atoms and 3 hydrogen atoms. One carbon, this is the bigger one is the carbon, and the smaller ones they are hydrogen atoms. Now this is a C single bond. This is a C single bond, and these are the attached ones. These are hydrogen atom. This is a hydrogen, this is a hydrogen. This is a CC bond, and each and every carbon is having 3 hydrogen atoms. Okay. Now what I am trying to show is, in this ethane molecule, the 2 carbon atoms are connected by a single covalent bond. That is a sigma bond. This bond is a sigma bond. Okay. While the remaining 3 valencies of each carbon, they are satisfied by hydrogen atoms. Okay. These 3 are hydrogen atoms. Now how do you write it? You write it as CH3 single bond CH3. This is how you write a ethane molecule. Okay. Now what I am trying to do is, if one of the methyl groups is kept fixed and the other one rotated, and the other one is rotated about the CC bond, a large number of momentary arrangements are possible. Now see here, when I am keeping it like this, right from top, when you see only one carbon and the 3 hydrogen atoms attached to it. Is it not? Now slowly what I am doing, I am trying to rotate the एक CH3 को मैंने फिक्सड रखा है और दूसरे को ऐसे 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 रोटेट करती गई. Right? Now here you find the CH3 groups, they are opposite to the one which is at the back. Okay, so these momentary arrangements, infinite number of momentary arrangements of atoms in space, they represent conformations of ethane. Now this is one conformation, then this is one conformation, this is another conformation, this is another, this is another, this is another, this is another. Like that you can make as many as possible. Now when I keep it one over the other, this is called as eclipsed conformation, where the electron clouds, that is C, this hydrogen, is it not? This is the hydrogen. The electron clouds are closer to each other. They are closer to each other. Okay. But when you shift it, then what happens? The electron clouds, they move a little far. Now, when I keep on moving it, now at this position, what you find? The electron clouds are at maximum distance. The electron clouds are at maximum distance. Now this is what is called as staggered conformation. Right? This is called as staggered conformation. And this is called as eclipsed conformation. When the electron clouds are closer to each other, it is called as eclipse conformation. Whereas when I rotate it and bring it in between the CH hydrogen bonds of the group which is below it, then this is called as staggered conformation, in which the electron clouds are far away from each other, and it is said to be the more stable conformation. Staggered conformation is more stable than eclipsed conformation. Eclipse means when it is one over the other. This is eclipsed. Right? And this is staggered. Right? So this is called as staggered conformation. These are conformations. Now what are conformations? You should know. They are the different spatial arrangements of atoms in space with respect to one another. That is called as conformation. Right? Now here, this particular conformation, what I am showing you right now, this is called as Newman projection formula. There were 2 people, one Sawhorse and the other one Newman. Now this is called as Newman projection formula. It is obtained by viewing the molecule along the bond joining the 2 carbon atoms. The carbon atom near the eye is represented by a point. Now here I have shown you as an atom, right? and these three are hydrogen atoms. These three are hydrogen atoms. And the one which is below it, that is also having 3 hydrogen atoms. Right? Now remember that this CC sigma bond can be rotated. It can be rotated. Okay? By keeping one constant, you can rotate the other. Right. So now here, the angle of rotation, which is called as torsional angle or dihedral angle, is this angle. This angle is called as dihedral angle or the torsional angle, this angle. So here, this is called as eclipse conformation. Remember, this is eclipse conformation. When the electron clouds of the top one and the bottom one, they are in line with each other. Okay? I am trying to make it with clay so that I can make you understand, because the models are there in the school. I am unable to bring it home. I suppose you have followed so far. Okay? So what is staggered conformation? What is eclipse conformation? This is what is the most important one. This is eclipsed and this is staggered. Okay? Right. Whereas in sawhorse, what you do is, it is the same thing, but the way you see, that is different. Like you see here. This is one carbon, and if you are going to show it like this, now you see these two are parallel to each other, and then right? This is called as sawhorse projection formulae. Right? It's the same thing, but you are seeing it at a different angle. Whereas Newman, you are seeing it from the top. Whereas sawhorse, you are seeing it sideways. That is the only difference. Is that clear? Both are same only, but only thing is the way that you're viewing it, that is different. So this is about conformations. Okay? So now, let me tell you about another one that is called as geometrical isomerism. That geometrical isomerism is seen in the case of alkenes. So I am trying to show, this is your CC bond, and these 4 atoms, they are hydrogen atoms, and this is planar geometry it is having, and this is the pi bond. What I am trying to show is one set of lobes above the plane and one set of lobes below the plane you will have. I am unable to show the other thing. Anyway, try to think it yourself. This is the p orbitals above the plane, p orbitals below the plane. There will be one pi bond cloud I can show here, and one cloud I can show it here. Now here this is a planar structure. Now here if I show it like this, right? Now what I can do at the maximum, what I can do is I can rotate it to this much distance. Is that clear? I can rotate it like this. ये पाई बॉन्ड है, ठीक है, इसको मैंने ये देखो, ये फ्लैट नजर आ रहा है आपको। अब ये हाइड्रोजन बॉन्ड, दिस इज वन हाइड्रोजन, दिस इज अनदर हाइड्रोजन. Now what I am trying to show you here is I am rotating it, but the rotation is restricted. I can rotate it like this and bring the hydrogen in the opposite direction. Is that clear? This is all I can do. But in the case of alkanes, I can thoroughly rotate. I can totally rotate it like this. Is it not? So this kind of free rotation around a sigma bond it is possible, but around a double bond it is not possible because it will break. Is that clear? So there is only restricted rotation possible, right? Okay. Now here when I am rotating it, say for example this is a different atom. Let me show you by means of a small ball, just for understanding purpose. Yes? Now what you see here, right? Now these are smaller ones, okay? Now these are bigger ones. एक निकालती तो दूसरा चला जाता है. These are bigger ones, these are smaller ones, right? Now the smaller ones, they are in opposite planes. Now supposing if I rotate this, then what I'll get? I'll get it like this. See how I have got now? Both the smaller ones are in the same plane, both the bigger ones are in the same plane. Okay? Now if they are in opposite planes, I can have only restricted rotation. If I am rotating it like this. Right? Now here they are in opposite planes. These two are in opposite planes. And these two bigger ones, they are in opposite planes. Okay? Now if they are in the same plane, if like groups are in the same plane, it is called as cis isomer. If the like groups are in the same plane, it is called as cis isomer. And if they are in opposite planes, then it is called as trans isomer. If they are in opposite planes, it is called as trans isomer. Okay? And the rotation here, in the case of alkenes, it is restricted. You can't rotate the way that you were able to do it with alkane. Is that clear? There was thorough rotation. 360-degree rotation was possible in the case of CC single bond. But in the case of CC double bond, it is not possible because the pi bond cloud will break. Is that clear? So what is geometrical isomerism? It is called as Cis Trans Isomerism. So Cis Trans Isomerism, what you have to understand is, if like groups are on the same plane, it is called as cis isomer, and if the like groups are in opposite planes, it is called as trans isomer. Right? So this is what is the main thing that we need to understand.